Hello class, welcome to this lesson on 3-3. So we're going to be focusing on polynomial identities and using them to factor and multiply expressions. Alright, so how can we use these polynomial identities to rewrite expressions if more efficiently? The learning goal, we want to be able to prove these polynomial identities and use them to multiply expressions as well as factor expressions for very special cases. The standard, or part of the standard, is to be able to prove these identities and use them to describe numerical relationships. So the vocab for this lesson is just knowing what an identity is, or a polynomial identity. So an identity is a mathematical statement that equates two polynomial expressions. One side of this statement can be transformed into the other side using mathematical operations. So the following four represent identities that will be used in this lesson. So this first identity right here is known as the difference of squares. So difference of squares. It's called the difference of squares because you're subtracting two perfect squares. In this case, a squared, b squared. So very simple rule. You're just going to, in order to factor a squared minus b squared, you're going to have a positive version and a negative version, a plus b, a minus b. So how do we go about proving this identity? To prove this identity, we're going to start with the right side, and then we're going to actually multiply or distribute. So we're going to be foiling the right side. Okay, so this is a FOIL, so a times a is a squared. Next, we're going to do a times negative b, which is negative ab. Next, we're going to do b times a, which is ba or ab, same thing, and it's positive though. And then next, we're going to be multiplying positive b times negative b, which is negative b squared. All right, notice that when you combine the middle terms, minus ab and positive ab, that they cancel. So ab minus ab is 0. So therefore, you're left with a squared minus b squared. So we went ahead and proved that. So it's equal to the left side. This symbol is just, this square symbol is just showing that you proved the identity. It's also known as QED, quod erat demonstrandum, and that just means that you proved the identity. So that's just a interesting little side note. All right, so now let's look at the second identity, the one on the bottom. This is the difference of cubes identity. So instead of doing difference of squares, we're looking at difference of cubes. So how do we go about proving that? Well, we're going to do the same thing as we did in difference of squares. We're going to be foiling, or actually distributing, on the right hand side. So we're going to multiply a minus b with a squared plus ab plus b squared. All right, so we're going to be distributing. A times a squared is a cubed. A to the third power, you got a total of 3 a's. We have a times ab is, well, you have 2 a's and 1 b, and it's positive. So we have a to the second power times b. Now we have a times b squared, which is just ab squared. Now let's do negative b times a squared, which is negative ba squared, or negative a squared b. It doesn't matter what order you put it in. Next, we're going to do negative b times ab, which is negative ab squared, or you can say b squared a. I like to put a first and b second, so I'm going to write it as AB squared. So negative, and I'm going to continue it over here, negative AB squared. Negative b times b squared is negative b to the third. You have a total of 3 of them. All right, and that takes care of the multiplication. So we went ahead and multiplied those. So now we're going to combine our like terms. So notice that you can combine a squared and a squared b right here. So notice that a squared b minus a squared b cancels. Also notice that ab squared minus ab squared cancels. And you're left with a cubed minus b cubed. And therefore we have proven the identity. All right. So I want you to go ahead and try to prove this one, try to prove this identity by doing a plus b times a plus b. So I want you to prove this identity by doing a plus b times a plus b and foiling that to see if you can get the right hand side. So go ahead and give that a try. Pause the video and we'll go over in just a second. All right, so let's go over the problem. So we want to rewrite a plus b squared as a plus b times a plus b. All right, so then we want to FOIL this. So we have a times a is a squared. Now we got to do a times b is ab, and it's positive. We have b times a is ba, or ab, positive. And then b times b is b squared. So we have a squared, and we have 2 of these, right? We have 1ab and 1ab, which makes a total of 2 ab's plus b squared. And therefore we've proven the identity because it matches the right hand side. All right, go ahead and give this one a try. See if you can prove that identity by multiplying the right hand side. All right, so let's go ahead and multiply the right hand side. So we have a times a squared is a to the third. We have a times negative ab is negative a to the second times b, because you have a total of 2 a's, but still 1 b. A times b squared is just ab squared, positive. Now we're going to do b times a squared, which is a squared b, or b a squared. I like to write the a first, so I'm going to do a squared b, and it's positive. And then we have b times positive b times negative ab. Positive and a negative is a negative. I have a total of 2 b's, so a b squared. Now we have b times b squared, which is b cubed. All right, so now we have a squared. Notice that a squared b is negative here, and it's positive here. So a squared b minus a squared b is 0. That cancels. We have ab squared here, and negative ab squared here cancels. So we have a cubed plus b cubed. And we have proven the identity because it matches the left-hand side. All right, proving these identities is not terribly difficult. You just got to multiply the polynomials. All right, next we want to be able to use the polynomial identities to be able to multiply expressions together. So we're going to be using this to multiply part A. So notice that part A, they're the same thing, right? Instead of having the FOIL here, you can obviously FOIL this problem. However, we're going to be using one of the identities to help us do this instead, okay? So since we have two of these guys, we can write this as 2x squared plus y cubed to the second power. And why do we write it to the second power? Well, we have two of them, and the reason why we want to put it in this form is because we can use one of the identities, right? So one of the identities was a plus b squared equals a squared plus 2ab plus b squared. So let's go ahead and use that identity. It's not hard to actually use that identity. All you have to do is, well, what's a? Well, a is equal to 2x squared. So we know that a is 2x squared. We know that b is y cubed, right? So that's a, that's b. So then if we use the formula, right, we have a squared. So that means it's 2x squared squared. That's the a part right there. Now let's do the 2ab part. So we got plus 2. A is 2x squared. B is going to be y cubed. So now we're done with that second part. Now we're looking at b squared. So we got plus, and then b is y cubed, and then it's squared. Okay, so this is my a squared plus 2ab plus b squared. So that's that identity, okay, at work. All right, so what is, well, we know that 2 squared is 4, right? So we got 4. And then what's x squared squared? Well, x squared squared, you're just multiplying those exponents. So 2 times 2 is 4. So when you have an exponent next to an exponent, you're multiplying them. All right, now let's look at this. 2 times 2 is 4. And we're going to combine x squared and y cubed together, like that. Y cubed squared. So what's y cubed squared? Well, you have an exponent next to an exponent, so you're going to multiply them together. So we have y to the 6. All right, and that's our expression. Now let's look at part B. So if we go back to the identity, let's go back to the previous identity. You have the positive version here, right? So this is the identity that we've been using. So I'm going to rewrite that identity for the second problem. However, since we're looking at a minus here, I'm going to say that b is going to be negative 3 here, okay? So I'm going to use the same expression, right? So a plus b squared is a squared plus 2ab plus b squared. But this time I know that a is 4x cubed, b is negative 3. So b is negative 3 here instead of positive 3. Okay, so in that case, we can still use the formula. So we have, let's do the a squared part first. So that becomes 4x cubed squared. So that's a squared. Now let's look at the 2ab plus 2. A is 4x cubed. B is negative 3. Plus b squared. B is negative 3, and it's squared. All right, so now we have 4 squared is 16, because 4 times 4 is 16. X cubed squared, you're going to multiply those two exponents. 3 times 2 is 6. 2 times 4 is 8. 8 times negative 3 is negative 24. Now we're looking at an x cubed there. All right. Negative 3 squared is negative 3 times negative 3, which is 9. And that is the expression. All right, go ahead and pause the video and give these two polynomial identities a try. All right, so we're going to multiply these expressions here. So notice that we have two of these. So we can write it as 3x squared plus 5y cubed squared. So again, we're going to be using the a plus b squared identity here, right? Which is a squared plus 2ab plus b squared. All right, so a in this case is 3x squared. B in this case is 5y cubed, positive. So we can go ahead and plug it in. So this is equal to a squared. So a is 3x squared. And then we got to square it. Plus, now we're looking at the 2ab. So we have 2 times a times b plus b squared. All right, so now 3 squared is 9, 3 times 3, and then x squared squared is x to the 2 times 2 power, so you're going to be doing 4. Now we have 2 times 3 is 6, 6 times 5 is 30, and then you're going to put the x squared and the y cubed together. Now we're looking at this part. So we have 5 squared is 25, and then 3 times 2 is 6, so it'd be y to the 6th power. All right, it takes care of A. Let's look at B. Again, we're going to be using the same formula, so I'm just going to put this in. This is the formula that we're going to be using. So in this case, A is equal to 5x cubed, and B is equal to negative 8y, because that's a negative right there. All right, so if we plug into this formula, we have this is equal to a squared, so that squared, plus 2 times a times b plus b squared. So we have 5 squared is 25, so we have 25. Multiply those exponents, so that's 6. We have 2 times 5 is 10. 10 times negative 8 is negative 80. We're going to put those two variables together, x cubed and y. All right, negative 8 squared. Negative 8 times negative 8 is positive 64. And then y times y squared is just going to be y squared. That's our final answer. All right, so we use polynomial identities to be able to multiply expressions, so to be able to square binomials. Now we're going to use polynomial identities to factor. So we're going to be using difference of squares, difference of cubes, or sum of cubes to be able to factor. All right, so let's go ahead and look at the first problem and factor that. So for the first problem, we have to be able to determine, well, is it a difference of squares or a difference of cubes? We know we have a difference, right? Because we have a minus sign. So we know it's going to be one of those formulas. Now, is this a perfect square right here? Is this what you want to ask yourself? Well, yes, because this is the same thing. I could take the square root of 9, right? The square root of 9 is 3. And I can write this as 3m squared squared. Okay, so this is a perfect square because I can write this as something to the second power. Okay, so if I were to do this out again, right, we know that 3 squared is 9, and we know that m squared squared is 4, m to the 4th. So this is a perfect square. In the same way, well, 25 can be expressed as 5 squared, right? So we can write it as 5. And then I can take half of 6, right? Half of 6 is 3. So I can write it as 5n to the 3rd power squared. So now I know that 5 squared is 25. And then if I multiply those exponents, I'm going to get back 6 for the power. So these are perfect squares. So this right here is a difference of squares. So we're going to be using the difference of squares identity. Okay, so this is the difference of squares identity. So we're going to be using a plus b times a minus b. That's one of your identities that we mentioned in the beginning. So now we know what a is. A is 3m squared. So that's a. And b is 5n to the 3rd. All right, so now that we know what a and b are, so basically if you take the square root of the first and the second term, that gives you a and b. All right, so now let's plug it into the formula. So this is equal to, so a plus b times a minus b. So now we're at this part right now. So we have a plus b, so a is 3m squared, plus b is 5n cubed. So now we're at a minus b. So a is 3m squared minus 5n cubed. And that's it. So you can do these pretty quickly if you know right away that it's a difference of squares. Now let's look at the second example. So notice that we have a sum here, right? So we're definitely not going to use the sum formula or the difference formula. We're going to be using some kind of sum formula where we have a plus b or something like that. Now notice that this is a perfect cube, right? Because it's x cubed. Is this a perfect cube? So can you take the cube root of 216 is what we want to say. What number, if you multiply by itself 3 times, will give you 216? So in that case, there's two ways that you can do this. You can take the cube root on the calculator. So on the calculator, you can do the cube root of 216. And that'll tell you what number, when I multiply by itself 3 times, will give me 216. And it turns out you get 6, okay? And that makes sense because 6 times 6 is 36, right? And then 36 times 6 is going to give you 216. So this is a perfect cube. So we can write this as 6 to the 3rd power. And this is obviously just going to be x to the 3rd power. So this is a sum of cubes. So this is the sum of cubes identity. And if you remember from that first page, from that identity page, the identity was a plus b times a squared minus ab plus b squared. All right, so what's a and b? A is equal to x, because that is what's being cubed, x cubed. and b is 6, since 6 is being cubed. So b is 6, positive. So now let's plug it into this identity. So for this this is equal to a plus b, so x is a, plus b is 6. And now let's look at the second part. A squared, so x squared, minus ab, so x times 6, b is 6 and a is x, plus b squared, so 6 squared. And then we just kind of simplify that a little bit and get our final answer. So we have x plus 6, we have x squared minus 6x plus 6 squared is 36. And that's our final expression. All right, now let's look at part C. Now part C, there are two ways that you can do this. Okay, so there are two ways to do this one. You can think of it as a difference of squares, or you can think of it as a difference of cubes. So let's look at it as a difference of squares first. Let's do that first. So this is method 1. So method 1 is difference of squares. So difference of squares. Okay, so you can think of x to the 6 as a perfect square. So if I take 6 and I divide it by 2, I get 3, right? So I can think of this as x to the 3rd squared. So that is a perfect square now, right? Because the second power is on the outside. 3 times 2 is 6, so that's how I get back to the original. Minus y cubed squared. So now you can think of these as perfect squares, right? So if you have this guy to the second power, this guy to the second power. Well, that's just going to be a squared minus b squared, right? So let me rewrite that. So you can think of this as a squared minus b squared, which is a difference of squares. And if you remember, the identity was a plus b times a minus b. So in this case, a is x cubed, b is y cubed. So if you just compare those directly. So we can use the formula. So let's use the formula here. We have a plus b, so x cubed plus y cubed. And then now we're doing the a minus b part, x cubed minus y cubed. All right, so these are perfect cubes. These are perfect cubes. However, there is no difference of cubes formula. There's only a sum of cubes formula. So we're going to be using the sum of cubes formula for this guy. So just kind of ignore this for a second. We're going to focus on the x cubed plus y cubed. So I'm going to just focus on this, okay? This is a sum of cubes right here. And the sum of cubes formula, I'll write it down. A plus b, a squared minus ab plus b squared. So in this case, a is x and b is y. So we can factor this. So we have a plus b, x plus y, a squared, x squared, minus ab, xy, plus b squared, y squared. So you see this guy that we just found? So this guy that we just found gets plugged in here. for our final answer. So our final answer is, we're going to plug this in there, so that's going to be in pink. So we have x plus y, x squared minus xy, this is the pink part, plus y squared. And then just rewrite that guy, just bring that guy down. And that's it. This is our final answer. Okay, so this is the fully simplified form. So we took the x cubed plus y cubed in the beginning and we simplified it even further. So we broke this down twice to get our final answer. So when you do these, sometimes you'll have to break it down twice or 3 times, depending on if you have multiple identities that you can use. All right, so this is the first way of doing it. I'm going to show you the second way, where you're doing the difference of cubes first, or you're doing the cubes first, and then you're doing, actually, I apologize. There's only one way of doing this. This is the only way of doing this. I apologize for that. There's only one way to do this. Yeah, I apologize. I said 2 ways. There's only one way. So you cannot do this with the sum of cubes because there's a minus sign here. So that's going to prevent you from doing that. All right, so this is the final answer. Go ahead and give this a try. So pause the video and use the polynomial identities to factor. All right, so let's look at the first part. So you can think of this as a difference of squares because you can take half of 8, right? So you can think of this as m to the 4th squared. You could take the square root of 9, right? So you can write this as, well, 3 squared is 9, and then half of 10 is 5. So you can think of this as 3n to the 5th squared. So therefore, this is a difference of squares, where you have a squared minus b squared. So in this case, a is m to the 4th, b is 3n to the 5th. So you can match those right there. That's b, and that's a. So we'll write that identity again. A squared minus b squared is a plus b, a minus b. We can go straight to it. So our final answer, this guy here, equals, so a plus b times a minus b. That's it, done. So for part B, you can think of this as a difference. So you're going to be doing either difference of squares or difference of cubes, depending on which one, whether they're perfect squares or perfect cubes. So 27 is a perfect cubed because 3 times 3 times 3 is 27. So if you don't know that, you could take the cube root of 27 on the calculator and you're going to get 3. You can also take the cube root of 343 on the calculator. And that'll actually give you, so if you were to do this out, 343, you would get, if you were to do this out on the calculator, you would get 7. So 7 times 7 times 7 is 343. So in this case, we can write this as 3. Now 9 can be divided by 3, right? So we know that this is a perfect cube. So we can write this as 3x cubed cubed. See, 3 cubed is 9, or is 27. And then x cubed cubed is x to the 9, because you're multiplying 3 times 3. Minus, and then we said that 343, the cube root of that is 7. And then we can take 6 divided by 3 to give us 2. So now if we check our work, 7 to the third power is 343, 7 times 7 times 7. And then 2 times 3 is 6. So we get back to our original. So this is in the form a cubed minus b cubed, which is a difference of cubes. So we can write the difference of cubes formula. And we have a minus b, a squared plus ab plus b squared. Okay, so what is a and b? Well, a is 3x cubed, and b is 7y squared. So if we use our formula, a minus b, a minus b times a squared, so a squared plus a times b plus b squared. So we got a squared, ab, b squared. So now we're just going to simplify a little bit, and we get our final answer. So we have 3x cubed minus 7y squared. So now we got 3 squared is 9, 3 times 3. And then 3 times 2 is 6, so it would be x to the 6th power. 3 times 7 is 21. And then put the variables together, x cubed, y squared. 7 to the 2nd power is 49. And then y to the 2 times 2 is y to the 4th. All right, that's it for the lesson, guys. Next time we're going to be talking about dividing polynomials. Take care, and I'll see you in the next one.